Hi, this is just a disclaimer that I do not own the name for the arm swinger system. I am just showing how I created the same sort of style movement system before. If you want to have that style of movements for Unity with more features, you can buy the arm swinger asset pack off the Unity store. Thanks. Alright, this is a tutorial, it's not me a little one, on how the arm swinger style movement works. I've had a bunch of people send me emails and comments saying, how does it work? So rather than talking to each and every single person, I thought I'd make one YouTube tutorial on how it works and how to create it. So I'm probably going to have a link to the entire project in the description once I finish with it. Not sure how long that can last because I'm probably going to host it on Google Drive or anywhere else that might be better. But here we go. So first up, we're going to be using Unreal 4.14 just because it's its latest version that isn't on a preview, which means it's most stable for now. So it's going to boot that up. Alrighty, once it's loaded up 4.14, we're going to create a new project under the new project tab. I'm going to base it off the virtual reality template. We don't need any starter content. It can be handy, but if you do have it, it'll take up more space and take more time to build it up. So I'm gonna create this as the arm swinger style tutorial. Oh, it's too long. Okay, let's just go with VR movement. That's what I called mine originally. Tutorial. Is that long enough? There we go. So VR movement tutorial, you can call a project with whatever you like. It just doesn't matter too much. All right, now we're going to be creating that. Give a bit of time to create that base template. Okay, here we are. There are a few things I recommend just to make usability. Just open up this little tab on the side, just so you have a better access to all the folders. So I'm going to start off by going to the motion controller map. This just means we have a big area to walk around in. For the tutorial, I'm going to show how the movement system works, but I'm not going to be doing any of the collision stuff of the player colliding with the wall. You guys can figure that out for yourself, or if I do get enough requests of people not being able to do it, then I will make a follow-up tutorial on that, because that'll take a little bit longer. I'm not sure, I don't want to make this too long. So there's a few things that we are going to do before we get straight into it. So we're going to go to Edit, and then Project Settings. We're going to move this tab up to the top. If you missed that, it was Edit, Project Settings. Then we're going to go down to Input. So this is where we create our own inputs. So there are a bunch of inputs already that Unreal recognizes, such as gamepad, keyboard, mouse, some motion stuff for mobile, just a big bunch of stuff for the platforms it works on. But we're going to be looking for motion controller grip. Now motion controller is generalized for both the Vive controllers and the touch. I'm not sure how touch works with that one. I don't have a touch myself to test out, but I've been working with the Vive. So for the grip, we're going to be using the grip 1, and we're going to add a second mapping with this button here, with grip 2 for the left side. And we're going to call this VR underscore movement underscore left. So the two inputs this is going to have, it's going to have pressed and released. It doesn't matter for 1 and 2, because on the Vive controllers there are 2 buttons either side, but they basically do the same action, and it's almost impossible, I say, to hit only one of the grip buttons without hitting both of them. So now we're going to add a second input action mapping. I'm going to call this VR underscore movement underscore right, just for R. I'm going to add a grip 1 R. Second one, grip 2 R. These only have, so if you're doing something with the axis, if I go bring it up now, grip axis, if you were doing something with that, that axes work from 0 to 1.
Or if you've got something like a joystick, it goes from -1 to 1 because of left and right. But you can mess around with that in your own time and look into different tutorials for that. Because I'm going to focus on the VR movement. Alright, so now we've got those set up, we can get straight into it. So we're going to go into, from contents, go into virtual reality blueprint, then go to blueprints, and we're going to go into the motion controller pawn. So this is basically like the hub of the entire player. Basically, this spawns the two controllers and the hands the player sees in game, and pretty much everything we'll be working around is going to be working around tick. Tick is a event that gets fired every single frame that gets rendered, which means it gets called a lot of times. Which means if you're doing something quite inefficient or doing a lot of stuff on there, it's not very good. You should be doing stuff based on input of what the player does, or on collision and that sort of stuff. Try and stay away from tick. But since ours is such a dependent thing on tick, or on how often it's been executed, we are going to use tick for this. So we're going to do Alt and click will disconnect any execution pin that are connected. I'm going to quickly go through some shortcuts on Unreal. If you're already experienced with Real, I'll have a little link saying to skip. But here we go. So we've got basics of when you click something. You can do Control C to copy and Control V to paste. Very simple one. We can delete that with the delete key. If you click it and do Control W, it just copies any one that's highlighted. So if I do Control W now, it does its copying. If I do Control V, it will paste it, the one I had copied last. This does work for big sections of code. So if I go this entire commented section, if I do Control W, I only get the comment. But if you do a drag across the entire section, if you do Control W, you get the entire section in the exact same layout it has. Yes, that is there. Anything else I could think of? Nope, when you're getting variables out, if you hold down when you drag out normally, you get either a get or set. But if you do Control drag, you'll get it, and if you do Alt drag, you'll set it. Just makes things a little bit easier and a bit quicker when you mess around with blueprints. So we're going to drag all this. I'm going to move out the way because we don't need that. That's to do with the base teleportation within Unreal. And we're going to be working with our own system. So there's a few things go over with how Unreal handles the controllers. If we go into BP Motion Controller, inside this we have a bunch of things. It's got like arrows, rings, to do with teleporting, arc spline, that's for teleporting as well. Grab sphere is the distance that it grabs objects from, but since we're not be messing around with that, we don't need to pay attention to that at the moment. The main thing we're paying attention to is this motion controller component here. Now this is the part that moves. The scene here, the root of it all, that doesn't move. That stays exactly where it is, where it spawned. Motion controller is the one that moves around, and that's why hand mesh is attached to that, not to scene. So, for any movement we're trying to read, we got to read it from motion controller. Keeping that in mind. Okay, so we're going to keep things a bit clean in here and just leave our things. I'm going to keep everything clean, so we're going to create our own function called check VR underscore movement. So this is only going to have an input. We don't really output anything about this. But in here, we're going to be checking which controller or controllers are activated for the movement. So we are going to be doing. We need to go back first and create some variables. So we need to create one called is left active, and we're going to create one called is right active. Quick check on these. These two need to be booleans. Booleans is basically it has two values of either being true or false, on or off, both the same. But basically we're going to check whether the left controller or the right controller is currently active. So to do that, we need to get our inputs we made from before. So
VR underscore movement. There we go. We've already got it. Left and right. So I have these slightly above. So VR underscore movement left. Now these are very simple. All we're going to be doing is basically setting those Boolean variables. So there's left and here's right. So when we're pressed, we'll say that left is active. And when right is pressed, we'll say it's active. Now if I can drag this down a bit, give itself a bit more space, I can click both of these and do Control W and have two of those. So now we can say when it's released, we want to say they are not active. So when the input's pressed, it is active. When it's released, it's no longer active. And that's what we're going to be working with. So back inside check VR movement, we're going to do a branch which works with booleans, separate into true or false. It creates two separate outputs of execution. So now we're going to do a check of AND. So these are also known as if statements. If you do an if, you get them as under the branch. So if the left is active and the right is active, then it will execute the true one, which if we just do click and press C, we'll create a comment. So we'll just say here for true, just to remind ourselves, if true has happened, we're going to check the movement distance of both left and right controllers. So we're going to check the movement distance of both left and right controllers first, and then we'll do some other stuff which we'll mention later. Okay, now we're going to peel off the false pin, do another branch. This time we're going to check if if both of them are active, then the only other three states there can be is left is active but right isn't, right is active but left isn't, or both of them are active. So we'll do a check for left if left is the only one that's currently active. If that's not true, then we'll do a branch. Check if is right. Oops, there it is. Is right active? So that's checking for right. So then if right is active, then we will do checking off the direction and movement distance of the right controller. Else, if it's still false, then neither of them are active, so we shouldn't move at all. Okay, so one of the important things about this is the direction. I'm going to try and keep things in functions, just try and keep things clean. So I'm going to create a function that gets get controller direction, and we're going to have an input, but we need to create the input type for this, so we're going to go back to the scene of the level, and within here we're going to go to right click, I'm going to create advanced asset, blueprint, enumerator. So enumerator is basically just, it works as basic integers of 0, 1, 2, 3, 4, how many you make, but it basically creates a name that's more readable to someone programming for it. So we're going to create a move, it's called the VR movement enum, underscore movement enum, and we're going to create this. So the three states we can get the direction of is only left controller, only the right controller, and then there is also both, when both left controller and right controller are being held down. We save that and close it, and we should never have to touch it again. But now, if we go into input and we go change the data type, which currently says Boolean, we go to VR underscore movement enum, there it is. We can click on that and it brings that up. we can call it the input type. You can give it whatever name you want to that. It just changes here and when you call it. So now we're going to do a switch on that. Just rather than if statements, makes things a lot cleaner. So we go see left. So we have execution pins of left, right, and both. So now we have here, already by default with the VR template, we have left controller and right controller as references. So we can control drag these out so we can get them. Now we want to get motion controller, because as we said before, the motion controller is the only bit that actually moves. The base of it doesn't actually move. Then get motion controller. There we go. So we've got both of those. Now we need to get forward vector. The forward vector is basically the direction it's pointing in. And it points, and it has this through 3 floats, which is like 3 decimal places basically, of x, y, and z. So the 3 axes of x, y, and z. If you want to look into directional vectors a bit more, you can look online. They do get quite complex. This is just the very base of it, and very basics of how they work. So after this, we're going to basically we want to get rid of the z axis. So the rate how we broke this, sorry, is we right click and click split structure pin, and that will break it. So it will break it into the core components of x, y, and z. Yep. So now we're going to want to drag off the x and go into make vector. We're not making a vector 2D. We're making a straight up vector. So there we go. And we only want to create the x and y because we don't want to see if we don't want to check if the player is pointing up in the z-axis, because unless you want to have a game where the player can physically, if they point the controllers up and move and start moving them, they move upwards. Unless you want to do that, then you'll need a z. But as we're not, I was trying to be standard and just be stuck to the ground. We're going to leave it on the x and y. So there we go. We have a vector now, only with the x and y. But now we want to normalize it so that we basically any direction that was pointing upwards is taken back into x and y. That's what normalize does. Yeah, it's quite important to have this, because I've seen a few games such as Onward have problems when you point the controller. If you point the controller up a little bit, you slow down, even though you're holding full forward on the touchpad. So if you want to move the fastest mount forward, you have to hold it directly pointing directly level to get the most movement out of it, which I don't think really should be happening. So yeah, we can do the exact same thing here. Since what we can do is we can go click all over this, go Control C, Control V, copy and paste it, change the get forward vector receiving from, rather than being left controller, we're doing right controller now. Whoops daisies, right controller. So now we have that. Right, I forgot to mention, for this function we're going to output a vector. So I'm going to create a new output by clicking on the input of this function. So we have this details tab. Then we're going to click new. We're going to click on the output section and click new. I'm going to create a output vector. And it's going to be of type vector. I'm going to leave this bit down here. Now, if you're going to have multiple outputs and stuff and lots of different things with functions, it's always best to create a local variable that will output into. So I'm going to create called our outputting vector. I'm going to change its data type from Boolean to vector. So now we know we're going to, anything we set to this function, to this variable, it will be outputted at the end once we hit this execution pin. So now we have the left and right controller. We need to set the output vector. So output vector, set it, and then output there, and the output pin of normalize is going to go into setting the output vector. We can do Control W just to copy that. Do that again. So this is for the right. This is for the left execution pin. Right now I'm going to move that up a little bit so we have a bit more space, but still getting a bit more space so it's still readable. Now both is going to be the same but slightly different. So we're going to have both of these here. So we can highlight all of those, do Control W. Now we're going to want to add these two together. And then we're going to want to divide by 2. So we're basically getting the mean. So we're adding them together and then dividing by how many there are, which is 2, because there are 2 controllers. And then we are setting that to the outputting vector. So what with that, we're basically getting, so if the controller has one controller pointing to their left, and they have their right controller pointing to their right, what we'll do is we'll basically find what is the middle point between those 2 controllers, and we'll move down that instead, rather than favouring one controller over the other. So we're going to set the execution pin there, and set the execution pin there. And that is getting the direction of the controller in that nice little function. So we can save that, compile it, everything's still fine, and we can close that function now. So if we want to get the direction of that controller, we can simply click here on our functions, drag it out, and there we have it. We have our input type of left, right, or both, and then we have our output vector. So, but before we start using the direction, we need to get the distance that the player has moved. Now for this, we need to track where was the controller on the previous frame. So by doing that, we need to have a variable that stores that sort of information. So we're going to have previous left controller as a vector, because the all position is a vector of x, y, and z. And then we're going to have a previous right controller. So this is what we're going to be saving our information of where the controller was in the previous frame was. We're not setting it yet. We'll do that a bit later on. But we're still going to use it though, because it's still helpful. So we're going to we could do the exact same of get controller distance. So create a new function for that. And we're going to have the output be a float, because this is going to be about how far has the controller moved since the last time you knew where it was. We're going to output that as distance. So we're going to move that quite far down because we're going to do a bit of math stuff now. So we're going to do another switch on VR movement enum. I'm going to create the input of controller type. I'm going to change the data type to VR underscore movement enum, and just drag that straight into the switch node. Okay, now we need to be getting we need to figure out the distance of the left controller, the distance of the right controller, and the distance that both of them moved for both. So we'll start off by doing left. So we're gonna create a macro just to make things a bit neater, and a bit easier. Difference between macros and functions is that macros you can have inputs, input execution, but you don't need them. So for this, we're just making, rather than having a big chunk of several nodes to get the left and right controller, we're just going to create a macro which shows as one node, makes things look a bit neater when reading back through it. So I'm going to read this as left controller position. I'm then going to get right controller position. I'm just going to remove the spaces from that. Oops, daisies. But yeah, so there we go. So I'm going to start off with left controller. So we're going to be getting the left controller variable and getting the motion controller from that.
and then to find out finding out relative only within the VR play space of where it is, rather than the entire game world. We're going to get the relative location, which is down here. We're working on relative rather than world, just because if the player is moving, we don't have to calculate that as well, and it just makes things a lot easier. So if the player was falling, it'll be calculating the z distance to where they're moving, so they'll be technically moving, it would think. It just makes things a lot easier using relative. So I'm going to use output as a vector. So I'm going to get we're going to put output position. I'm having some struggling typing today. And we're just going to do the exact same thing for the right controller. So we're going to output vector output position, and then we're going to be getting this is for the right controller, so we're going to get the right controller variable, get that, get motion controller, which is, you need to put a space between motion and controller for it to recognize it properly. There we go. Get relative location, and then we're just gonna output that. So basically, this entire macro just saves us having these 3 nodes every time. Which you're never going to get anything else off them. So I'm going to close those now since they work. So we can now get off here. So we can get left controller position. So there we go. So that's where the controller currently is. And we'll use previous left controller to figure out where it was last. Now we're going to minus that off. So if the controller has moved forward on the x-axis, we'll find by 1. We're going to basically take away where it was last time to find out that it's only moved forward on x by 1. Now to change this from a vector, which figures out where it's moved last time on the x, y, and z, into a float, we're going to do a helpful node from Unreal called vector length, which basically puts into a more readable term of figuring out how far it's moved in a vector into a float, so it gives us a nice readable distance. So there we go, that is our distance we've moved. So that's what we're going to be outputting. So for the same as last time, I'm going to create a local variable called output distance, and this time I'm going to change the data type from vector to a float. There we go. I'll put that. So execution pin from the left. I'm going to say execution pin to there. Now we need to set our output distance as the variable that's going to be taken out. There we go. And then I do the exact same by copy and pasting it for the right, except now we need to change these 2 nodes here from left. So we need to right controller position. There we go. And we're going to get the previous right controller. And then have that going on to the output. Now for both of them, we need to get both of these, add them together, and put them out. So we'll highlight just both of them together. Control W to basically copy and paste them. Press add, and we'll get float plus float. So we have them both added together, and then we're going to go to set output distance, and there we go. That's what we're outputting for both of them. There we go. So there we go, the nice function to re-get the distance of when the controller's moved since the last frame. So there we go. So now we can have a nice little function to drag off here for true for both of them. So we can get distance, get controller distance, and change the controller type to both, because that's what this one is. Just resize that a little bit. So now we have the distance the player's moved. The next thing I want to do is get direct. Why is it finding it? Oh, check controller direction. Sorry. Check controller direction. And we want to change that input type to both as well. So now we want to drag off here. We want to have this multiply the float, the vector. So basically we have the direction we're pointing in, and we're going to multiply that by the distance we want to move, which gives us a nice amount we're going to move. And now this is the amount we're going to add to our player location. So we can create a nice little function node, another function. It's called add player movement, which is we're going to have an input type of a vector called the movement input. And then from that, we're going to be doing set actor location. So we're going to do a sweep check. So basically, it doesn't really matter because I'm not doing any sort of collision checks at the moment. And then from that, we're going to get actor location. So we're going to say, hey, wherever we currently are, we're going to add the amount we want to move to where we currently are to give us the position where we want to be. So that's just very, very few nodes, this one. Quite simple, just another function to keep things clean. So back into check VR movement, we're going to use the add player movement. Oops, there it is. So we're just going to draw the execution pin from that into check controller direction. Take the amount we want to move and plug it into movement input. And that alone should move the player. Now that was only done for both. So what we can do now is we can do it for the others now. So we just drag over all of them. Do Control W. So now we can change the control type to left for the left section, and do another Control W, and change it to just for the right section. So if both of those are true, there we go. We're setting all the stuff, all of the direction. So we're getting the distance, then we're getting the direction, then we're multiplying those together to get the movement we want to move in. Now, on the bottom of false, so if nothing happens, we still want to do something, and that is to check, basically setting where the player controller is this frame, and we want to do that last. So at the very end here, we want to do is set previous left controller, and after that do a set previous right controller. So we'll drag these out just a little bit further, and we'll get left controller position. A nice, neat, tidy one node. Right controller position, we'll get that one as well, and we'll drag that into the previous right controller. Tie those two together, so once it executes left controller, it'll then execute the right controller. Setting of that variable, and we're just going to drag off here and create a reroute node. Reroute node doesn't really do anything, it just makes things look a bit cleaner when you have all these execution pins all over the place. So at the end of each and every one of these, we want this little, so setting controller position for the next frame. And we also want it to come off false, because otherwise if the player stops moving the controller and they have a big movement before they start a big difference in movement, since they're doing it next time, then it will calculate that and the player will have a big jump when they start activating the movement system again. So if you go with any execution line, you can double click on it and double click on it and it'll create an execution pin, which just makes things nice, neat and tidy to read. Yeah, so now if all of this is done, this should work. So if we go back, we go checking our event graph, now we've got one little thing that this wouldn't worked. It's because we've got nothing coming off tick. So that entire thing, all that time we spent making, that is not running right now. So what we need to do is drag off the event tick, do check VR movement,
There we go, we have that node. Now, if you give me a second, I'm going to have to remove my headset to check if it works. So as this is an entire VR project, and this is entirely for VR, we need to go, before we click play, we need to click the down arrow over here and go into VR preview, and that boots it up in VR. For some reason, when I tried this before, the player moved really fast. So that's why I was dividing by 100 to make it slower. But yeah, we don't need divide. It seems to be fair enough as it is, with just distance going straight into the multiplier. But if you want to have a movement speed, you can create a new variable. Let's call ours, movement speed of type float. And then we go control drag, get the get of this, multiply it by another float. So we'll leave it as 1 for now, just to show the speed that you move at. And make it go in there. So that's how, if you want to have a game where you move really fast or really slow. Again, be careful when you're doing this if you're going to publish a game, because when you're developing, sometimes you might get motion sick prone or whatever to what you're making. And whatever, if you move really fast, because when I tried my game, oh yeah, it's fine if you move really fast. I've had other people complain, oh yeah, if I move really fast after a little while, I do feel a bit dizzy. So just be careful of that, of how fast you're making the player move in the environment. So yeah, I'm just going to leave that at 1. If I'm going to click on movement speed over here, now on the details tab, we'll change the movement speed from 0 to 1. So we actually move. So now if I go click play, and I take my headset off, you should see that you should move. Oh, also, debugging. Quick thing, if you've never used Unreal before, if you're wanting to see what inputs, what variables, what they're actually reading, and what they actually have, this print string node's really handy. It's just simple, right click, print string, and if you drag most variable types onto it, like here's a vector, drag it on there, it will spawn a conversion node from vector to string. Make things really nice and easy. It's just really handy to see what's going on with your variables, and that's what I use to see what's going on. So yeah, let me go back straight into here now. So that is that for the movement system, and that's how it works. If anyone's got any problems or got stuck, let me know in the comments, and I will try and help you out as much as possible. I try to make this as readable as possible and as easy for some people who haven't really used Unreal before, and hopefully not too slow for those of you who have. Any problems? Yep, let me know. I think that's everything for this. Yep, thanks for watching, and ta-ra.